So let us continue with the lesson motion. Now in that, the next heading is equations of motion by graphical method. Graphical method is by velocity time graphs. Now there are three equations of motion. The first one is v is equal to u plus at. Second is s is equal to ut plus half at square. Third is 2as is equal to v square minus u square. In this, v is the final velocity, u is the initial velocity, a is the acceleration, t is the time, and s is the distance covered. That's what I have written here. Where u is initial velocity, that is starting velocity, v is final velocity or terminal velocity, a is the acceleration, s is the distance traveled, and t is the time. Okay. So these equations of motion we have to get it from the graphical method, that is the velocity time graphs. Okay. Now we will see the next, that is the heading, equation for velocity time relation. That is the first equation. Let us get it from velocity time graphs. For that, we will consider the velocity time graph of an object moving with uniform acceleration a, initial velocity u, final velocity v, which it attains or which it achieves in the time interval of t seconds. That is, initial velocity is v and it is traveling with acceleration a. So its velocity reaches v in a time interval of t seconds. I will draw this velocity time graph. So I have drawn the velocity time graph. Okay, this y-axis is the velocity. So I have considered here an object moving with initial velocity u. Initial velocity u is represented by OE and it's moving with acceleration. So in a time interval of say t seconds, so OC is equal to t, its velocity reaches v. Okay, in a time interval of t seconds, the velocity of the body reaches v. Initially it was traveling with u, and in a time interval of t seconds, its velocity has become v, and v is represented by bc. Now what we will do is, we will draw one perpendicular like this. Okay, we will draw one perpendicular OD. OD is drawn perpendicular to BC. Okay. Now you know OA, this becomes a rectangle. That is, OA DC becomes a rectangle. So OA should become equal to what? DC. Okay. So let us continue. So what is OA? OA is equal to U. BC is equal to what? V. OC is equal to T. And we have drawn OD perpendicular to BC. So what becomes rectangle? OADC. It becomes a rectangle. OADC becomes a rectangle. So OA should be equal to DC. So if OA is equal to U, then DC should also become equal to U. Now, how can you write BC? BC you can write as BD plus DC, isn't it? So BC is equal to BD plus DC. Look at the diagram, you will understand. Full BC is equal to what? BD plus DC. You know BC is what? V. Full BC is V. BD we don't know, let us find it out. And DC. DC is the same as OA and DC is equal to what? U. So in place of DC I will write U. So what will be BD? BD is equal to V minus U. Okay. So we get BD is equal to V minus U. Now you know the definition for acceleration. Acceleration is rate of change of velocity, or acceleration is equal to change in velocity upon time. So acceleration A is equal to this, in this BD represents the change in velocity, because BD is equal to what? V minus U. Final velocity minus initial velocity is change in velocity. So acceleration is equal to BD upon time. BD is change in velocity, V minus U. So BD is what? V minus U upon time t. So V minus U becomes equal to what? V minus U is equal to, cross multiply this, A into t. So you got V minus U is equal to AT. Okay. So what do you get? V minus U is equal to, V minus U is equal to cross multiply. If you cross multiply, V minus U is equal to AT. Okay. So V is equal to, you transfer this minus U this side. When you transfer minus U this side, it becomes plus U. So you get the first equation, that is velocity time relation. V is equal to U plus AT. Okay. So this is the equation for velocity time relation of motion, or the first equation of motion by graphical method. Please take down all these notes in your fair, and we'll meet in the next class.